Hey guys! Today we are going to take a look at adding fractions with unlike denominators. But before we dive deep into something new, let's take a look at something you're already familiar with. So in the past, you've added fractions with like denominators that are the same. Now remember, in a fraction, the top number, the numerator, represents my part. The bottom number, the denominator, represents my whole. In order to add fractions, it's very important that your denominators be common because it shows a common whole. And it makes it easier to look at too if you look at this model. I can see that 1/3 plus 1/3 equals 2/3. And if you look at the model, if I have 1 out of 3, and then I put together with that another 1 out of 3, you can see that I end with 2/3. So here we have the equation 1/4 plus 1/3. You can look at these fractions until they have unlike denominators, and you can look at the models to see that they do not share a common whole. So there's something that we have to do before we add. We cannot just add across 1 plus 1 and 4 plus 3. We need to have a common whole. So we have to do something you're already familiar with. We have to make equivalent fractions. Now, when we make these equivalent fractions, we are going to look back at the denominator. Our denominators are 4 and 3. So what we're going to do is we're going to take a look at our multiples of 4 and our multiples of 3. If you look here, I have my multiples of 4 and my multiples of 3. Since we're finding a common denominator, I'm going to find the first number they have in common, which, as you see circled, is 12. Now, you can look down on this list and you can see that they also have 24 in common, but it's always just easiest to use the smallest number they have in common, the least common denominator. Since my denominators are 4 and 3, and there's a 12 in both of my 4s and 3s, this is my common denominator, and this is the number that I am going to use to make my equivalent fractions, so the fractions in the original equation share a common whole. So here we have our original fractions. We have 1/4 and 1/3. I'm setting up an equation to make equivalent fractions with a denominator of 12. This is the common multiple, the common denominator that we found. So when I look at my numbers of 4 and 12, I can see that my number is going larger, so I'm going to use multiplication, and the same for here. Now remember, we've made equivalent fractions before. Whatever you do to the bottom, you must do to the top. Since it's an equivalent fraction, we must treat the numerator and the denominator equally. So since I'm using multiplications, I'm going to remember my math facts and think to myself, okay, how do I get from 4 to 12? Well, I know that 4 times 3 is 12. And remember, whatever you do to the bottom, you do to the top. So that means I'm going to do 1 times 3, which is also 3. That means 1/4 is equivalent to 3/12. The same with 1/3 to how many 12s? Well, how do you get from 3 to 12? Well, 3 times 4 is 12. And whatever I'm going to do to the bottom, I'm going to do to the top. And 1 times 4 is 4. So now I have two fractions that have the same value as the original, but now I have like denominators, which makes it okay to add. So here we have the equivalent fractions that we just made, 3/12 and 4/12. And remember, that's equivalent to 1/4 and 1/3. We used multiplication to make equivalent fractions, but I wanted to show you these models so you know that even though we used multiplication, these are not larger fractions. They have the same value. And you can tell by looking at the shaded regions here that it's the same from 1/4 to 3/12 and 1/3 and 4/12. So there is only one thing left to do. We're going to find our sum and add 3/12 plus 4/12, which gives us a final answer of 7/12.